So this is really kind of going to be our last formal lecture. So this is for class for Friday, June 5th. And believe it or not, a week from today is actually your final. So this isn't anything new that I'm going over. I'm actually going over some of your homework problems, some problems that are very similar to your homework problems, just trying to give you a lot more examples. I've also included two different YouTube videos. One's short and sweet, like 5 minutes, and the other one is quite lengthy. It's more geared for nursing. However, the terminology and everything is the same, and that's about an hour. I included those in here just to give you some extra options to look at. If you got it and you don't need to look at that, fine. But if you feel like you have something else that you'd like to go ahead and take a look at, I'm hoping that will help you. So with that being said, I did just kind of post a little, and you know my dog's gonna bark because she's standing right here again. I did post that we're gonna have a Zoom next Monday, June 8th, and then I'm gonna do it for an hour and a half. I was able to do that with Zoom. And we'll kind of conduct a class or whatever, and it's going to be for questions that you have on math. I'll talk a little bit more about science tomorrow when we have our weekly check-in Zoom, just kind of telling you what that's going to look like. I do have one more lecture for that class for tomorrow, but for right now, let's just go ahead and get through this. I did type out as much as I possibly could so you don't have to go through all my terrible drawings. This actually format hopefully works okay, so I just created this PowerPoint. Alright, so we're going to be looking at this type of question, and this actually comes off of your homework. So you're going to be looking at what will your working number be in milligrams per mil for the concentration if the solution is 0.15 rather percent. Okay, so really what does that mean? Okay, so like I said, this one kind of hopefully is a little bit better format, unfortunately. So all I'm really missing here is my lines. Okay, so what does that mean? What does oh, that one turned out much better. So what does this mean? So if you're looking at this, if you look at the 0.15%, okay, you are basically saying that that is the same as, okay, that is the same as 0.15 grams over 100 mils. That's saying the same thing, okay? And then we have to turn our grams into milligrams. Okay, so we would basically move 3 decimal places over to the right, or multiply it by 1,000. And we have 3 zeros and 1,000, so 3 place values. Okay, not 3 zeros, just 3 place values. Okay, so that turns the 0.15 to 150. So it changes 0.15 to 150. By adding 3 place values. So now we've changed 0.15 grams is the same as 150 milligrams. And then your 100 mils is going to stay the same. Alright, and then what we need to do with this is we divide then both the top and the bottom here by 100. Right? So we just divide both by 100. So if you take 150, you divide it by 100, or you knock out at least 1 zero, then you have 15 divided by 10, so that's 1.5. Okay, so your working number then is 1.5 milligrams per 1 mil is what this concentration means. Okay, this makes more sense, 1.5 milligrams per 1 mil. Okay, so that's all you're doing is you're converting that. You're not doing the drug dose volume thing right now, concentration thing. You're just trying to get your working number. Right, so what if we look at, this is a similar problem, not exactly the same, very similar to number 3. I just kind of changed the numbers around so I wasn't handing over everything to you. So now instead of looking at a percentage, we're looking at this ratio. Okay, we're looking at 5 to 15. Okay, so 5 to 15 then is really the same as 5 grams to 15 mils. Okay, again, we want to change grams to milligrams, so we have to multiply the 5 by 1,000 or move 3 place values over to the right. So our 5 grams has turned into now 5,000 milligrams. Okay, so now we need to get our working number. Okay, our working number is basically, we'd like to try to get it down to 1 mil. So we have to divide both the top and the bottom by 15. So obviously the 15 divided by 15 gives us the 1 mil. If we take 5,000 and divide it by 15, you're going to get 333.333, keeps repeating itself, milligrams. So that is your working number. Now you have, for a 5 to 15 solution, the concentration you have equals out to 333.33 milligrams per mil. Okay, so that's a couple of the different problems that you have, and I'm hoping that format will kind of help get you through the other problems on your homework. Now we're going to be taking a look at the volume times the concentration equals your dose problem. Okay, so with all these like little mini story problems or whatever, you need to identify what you're trying to solve for and what information you're giving. Okay, so this is saying a unit dose of Atrovent contains 2.5 mils of a 0.2% solution. How many milligrams of an active ingredient are in this unit dose? Okay, so when you're looking at, and I probably should have put mils here, but now that I'm looking at that, so if I'm looking at trying to identify everything, anything that's set up in the ratio format or the percentage format, that's going to be your concentration. Okay, so this is your concentration. All right, and we're going to work with this number a little bit more, just like we did. What's our working number is basically what we're saying here. What is my working number? So these are fractions, or look at ratios or whatever, but they're fractions. They should have a little line underneath it like a fraction. It's just, I just wanted to do it this way versus the slanted line. So we're identifying what parts of our problem that we know. So a unit dose of Atrovent contains 2.5 mils. So that's my volume, okay? It's in milliliters, or remember liters is like your base unit for volume, okay? Concentration then is usually in a percentage or some type of ratio format. And then I'm trying to solve for dose. Okay, so my volume is 2.5 mils. That's pretty straightforward. I don't really need to do anything with that. But this concentration is kind of, we want to make that into more of a working number. So as we saw before, 0.2% is the same as 0.2 grams over 100 mils. Okay, so make sure you have your line. And then we got to move 3 decimal places over to the right to change my grams to milligrams. So that changes the 0.2 grams to 200 milligrams. Just like earlier we had, what, 0.15 grams, and we changed that to 150 milligrams. So now we're looking pretty much at the same thing. So now we have 200 milligrams over 100 mils. This one's easy enough just to, divide it by the top and the bottom by 100, or just get rid of your zeros. So now you have 2 milligrams per 1 mil. Okay, that is now your concentration. So that is this one. So now you have your concentration. So you're going to take your volume times your concentration, and that's going to give you your dose. So let's just straight across math. 2.5 times 2 equals 5. Your 1 stays at the bottom, your milligrams that would stay there, your mils would cancel out. So this was 2.5 mils. I didn't do a very good job of setting this up beforehand or writing this out, I guess. Now that hindsight's always 20/20. So you would go ahead and you would, cross out your mils, try to cross them out. Okay, and now you have 5 milligrams. Okay, so that's your dose. Hopefully that is clearer than it really looks right now. All right, I have a couple more. Okay, so now we're looking at just a different type of problem here. This is something I think a little bit more familiar. We're not doing the volume times concentration equals dose. We're just kind of comparing these. So it's off of a different worksheet. So if you have a solution basically that contains 3 milligrams of an active ingredient in 3 mils, how many mils are required to give 9 milligrams of the drug? So it's just a different way of looking at drug calculations, just a different type of question. So they're not all super intimidating. So what it's saying here is that we have 3 milligrams in 1 mil. Okay, so that's what this is saying. 3 milligrams in 1 mil is equal to, okay, so this is just a ratio or proportion. We're finding the equal amount. So 3 milligrams to 1 mil is the same then as 9 milligrams to how many mils? Okay, so there's a couple different ways of looking at this. You can say, what do I do to the 3 to get to 9? I have to multiply it by 3. Okay, that's one way. So if I multiply the top by 3, I have to do the same thing to the bottom. Okay. Or you cross multiply, which is probably the easier way. Cross multiply, 9 times 1 is 9, divided by 3 gives you 3. Okay, so your x here is 3. So this is just algebra. Okay. All right, moving back on to a couple more of these different problems. So we've been, I think, pretty okay, I'm hoping, with looking at volume times concentration equals dose. Okay, now we're going to go ahead and be solving for a different variable. Okay, so now we want to solve for volume here. So in order to solve for volume, then we have to take our dose divided by the concentration is going to give us our volume, right? So we have a 1 milligram dose, it's telling me that. Okay, so that's my dose of a 1 to 100 solution of epinephrine. Okay, so it is asking how would be how many mils. So a 1 milligram dose so this is really similar to one of your other problems. I just changed one of your numbers. So I have a 1 milligram dose of a 1 to 100 epinephrine would be how many milliliters? Okay, so again, my dose is straightforward there. We have 1 milligram, which I put down here. All right, but we don't want to worry about that right now. Let's worry about this concentration, this 1 to 100. What the heck does that mean? Okay, so 1 to 100 is going to be the same as 1 gram over 100 mils. Now remember, we have to change the grams to, you're saying milligrams, okay, to milligrams. There's 1,000 milligrams in 1 gram. We're moving 3 decimal places over. So we're adding 3 zeros. So now we have 1,000 milligrams over 100 mils. Okay, so we get rid of our zeros, or we divide both the top and the bottom by 100. And now we have a 10 milligram per mil is our concentrations. 10 milligram per 1 mil. So now you have to take basically your dose, Okay, this is your dose, your 1 milligram. Divide it by your concentration, which is 10 milligrams per mil. Okay, so as we know, so that would be the 1 milligram. Okay, or you just put a 1 over it, divided by your 10 milligrams over 1 mil. And so you know what to do when you're dividing fractions, I hope, right? We have to flip it. Okay, again, this is mil, I'm sorry. My dog is chewing on something. I have to go check and see. Okay, so we flip it. So here's our flipped version, 1 mil over the 10 milligrams. So we multiply, so we have 1, again, just 1. Our milligrams cancel out. So we basically have 1 mil per, or 1 over 10. So 1/10, that is 1/10. Okay, if I take 1 and I divide it by 10, I get 0.1 mils. Okay, so that's 1/10. Okay, it's either 1/10 in the fraction format or 1/10 in the decimal. But just for fun, if you take 1 divided by 10, you get 0.1. All right, almost there. My last page is just basically those different video links. So here is another problem. So we're looking at the dose strength that we have on hand is 15 milligrams per mil. The volume, what volume rather, so we're looking for volume, will deliver a 500 microgram, okay, so that's not a typo, mcg, dose to a patient. Okay, so the dose on hand, this is the strength of the concentration. It's 5 milligrams per 5 mil. What volume then will deliver a 500 microgram dose to a patient? Okay, so one of the first things that we need to do is we need to get rid of this micrograms, okay, because we're used to working with milligrams. So the first thing we need to do is convert our micrograms to milligrams. And there's 1,000 micrograms. They are a smaller unit in 1 milligram. Okay, so that means our 500 microgram dose is now going to be 0.5 milligrams. So because the micrograms are smaller than the milligrams, we need to divide the 500 by 1,000. So I'm going to move 3 decimal places over to the left. Okay, so 500 then turns into 0.5. So you think of moving 3 decimal places, 1, 2, 3. We have 0.5 milligrams is the same as 500 micrograms. Again, you're dividing by 1,000, which is our dose. Okay. Then we have to look at the concentration. Okay, so this is our concentration, but we should be able to look at that and say, well, let's see, I really like to get this down to working with 1 mil. So I have to divide both the top and the bottom by 5. Okay, so that's basically just reducing my fraction from 5 over 15 rather over 5 is going to turn into 3 over 1. Okay, so now we have our dose. Okay, so our dose divided by our concentration. Okay, and again, bear with me here. I'm going to go ahead. So we have our dose is our 0.5 milligrams. Oh my goodness. These guys are a pain. Okay, and this is divided by, but we know what we need to do. We divide a fraction, we have to flip it. Okay, so this is going to turn into 1 mil, and the 3 milligrams is going to go underneath. Okay. now you have a 1/2 milligram over 3 milligram per mil. Okay, so sorry, this is still over. Oh no, you got the milligram right there. Okay, never mind. So we're looking for volume, right? Sorry, I put it on pause for a minute. So anyway, your milligrams cancel out. So if you have 0.5, and if you divide that by 3, you will have 0.167. Okay, so 0.5 divided by 3 gives you 0.167 mils. Okay? Alright, and now your next one are your 2 different links. Hopefully they can help you out. Hopefully this has helped you out, and I will see you all soon.